So topic number 5, which is forces between two parallel current carrying conductors. So in this subtopic, you have to be able to explain magnetic force per unit length of two parallel current carrying conductors, and then apply the magnetic force per unit length punya formula lah. So forces between two parallel current carrying conductors, for when there are two parallel conductors, they will be exerting a force on each other when there are current passing through both of these current carrying conductor lah. So the force will depends on whether the current will be in the same direction ataupun in the opposite direction lah. Kalau same direction, they will be producing an attractive force. Kalau in the opposite direction, it will be repulsive force. So each conductor will then, each conductor will be exposed to the other's wire's magnetic field lah, macam ni. So it will be causing it to experience the magnetic force lah. Alright, so try kita tengok untuk current in the opposite direction. So the magnetic field lines will be here, di wire yang ini. So maksudnya bila kita guna Fleming's left hand rule to determine the direction of force, it will be pointing to the right. Okay, kamu buatlah guna kamu punya left hand. Lepas tu kita tengok yang di sini pula. Bila the magnetic field is like this, so you can either use right hand palm rule ataupun Fleming's left hand rule lah, okay? So kalau kamu guna palm rule, our thumb will be pointing the direction of current, lepas tu the palm is telling us the force. Magnetic field tu dia bagi tahu the direction of the other fingers is the direction of magnetic field lah. Okay, so make sure you are able to understand how to determine the direction of force. Lepas tu, a current in wire 1 will produce a magnetic field at wire 2, which is in this equation. Lepas tu, wire 2 pula tu akan experience a magnetic force of F21 lah. F21 tu pula akan equal to BIL. So, kita tahu B is equal to this equation here. So, kita akan dapat satu formula macam ni lah. So, hence, force per unit length punya formula is this one here. Okay, so sekarang ni kita akan apply the example number 5. So we have two long parallel wires placed 0.25 meter apart in vacuum lah. Okay, so they are 0.25 meter apart. And then sekarang ni kita perlu sketch a diagram to show clearly the direction of the force on each wire lah. Okay. I'm not gonna label it then. So since this is in the same direction, if you determine the direction of the magnetic force, I'm gonna draw the magnetic field dulu. So direction of magnetic field, kamu akan guna right hand grip rule lah untuk cari dia. Lepas tu di sini lagi. Okay. So, we are going to be focusing on this point. I'm going to use black. And this point here. Okay. So, sekarang direction dia adalah, this is like this. And then this one is also like this. Okay, so sekarang ni direction of magnetic field lines. Di sini kamu akan lukis tangent to the, it is gonna be tangent to the magnetic field lines ah. So kamu akan dapat something like this, and then this one is something like this. Okay, so this is B, this is B. I'm gonna label it as 2. This is B1. So sekarang ni kamu akan guna kamu punya Fleming left hand rule ataupun right hand palm rule. Okay, so sekarang saya akan guna Fleming left hand rule. So you should get the direction of magnetic force to be pointing this way. Kalau kamu tidak dapat, kamu perlu minta ajar kawan yang dapat lah, basically. Or just ask me lah. So this is the current lah, and then this is the force by 2 on wire 1, force by 1 on wire 2. Okay, macam tu. So remember our thumb is telling us the direction of force the pointing finger is the magnetic field, and the current is telling us the direction of, middle finger is direction of current, pointing finger is magnetic field, thumb is the force. Okay, I'm actually trying to do it with my Fleming left hand rule. So itulah saya macam blur sikit bila mau bercakap ni. Sabar, let me just try it. Okay, wire is begini, so current is like this. So yeah, you will get the magnetic force to be pointing here lah. Alright, so that is basically the diagram. And then we have to calculate the force per unit length between the two wires. So yang ini kamu just perlu apply formula. So basically, if you have problem determining the direction, just let me know. I'll help you during class lah. Mu naught I1, I2, 2 pi d. So I1, I2 is the same. So it will be 2.4 ampere. And then this is the distance between the two wires lah. Okay, so kamu substitute 4 pi, 10 negative 7, 2.4, 2.4 divide by 2 pi, d is 0.25 meter. So kamu akan dapat the force per unit length to be equal to 4.608 times 10 negative 6 Newton per meter. Okay, so that is the value of force per unit length. Untuk soalan C pula, dia minta if the current in one of the wires is reduced to 0.64 ampere, calculate the current needed in the second wire to maintain the same force per unit length as in B. So F over L mu naught I1 is the same, I2 is the one that will be reduced to, sorry, not equal. I2 is equal to 0.64 ampere. They're reduced to 0.64 ampere pula. So apa yang kamu buat? Kamu just substitute lah 0.64 ampere jadi I2 nanti. And you will be, oh sorry, I1, wait, let me just check. One of the current is reduced. Calculate the rate. Okay. So sekarang ni kita akan let, we are gonna let I1 to be equal 0.64 ampere. So sekarang ni kita perlu cari current di wire number 2 supaya force per unit length tu masih constant. So saya susun supaya the current in the second wire will be the subject, 2 pi d over mu naught I1. Okay, so sekarang ni kita tahu F over L yang kita dapat tadi adalah 4.608 times 10 negative 6. So darab dengan 2 pi, the distance is 0.25 meter tadi. Lepas tu this is 4 pi times 10 negative 7. And the current in wire 1 is reduced to 0.64 ampere. So the current in the wire should be 9 ampere, so that the force per unit length masih sama as the one in part B. Okay, so that is the solution for example number 5.